Hey everyone, welcome back to today's video, where we will explore one of the most critical yet often overlooked aspects of database administration, which is backups and restore. Whether you are managing a small project or a large enterprise application, having a solid backup and recovery strategy can save you from potential data disasters. So let's dive in. First, why backups are essential. There are four reasons. There are many more of that, but like there are four reasons that come to my mind. The first thing, maybe we have like some accidental deletion, like a single drop table or delete statement can wipe out crucial data. Number two, hardware failure, like disks wear out, like servers fail. Your data shouldn't suffer because of this. Number three, security incidents, like hacking or or anything that can corrupt your database. Number four, compliance requirements like industries like finance or healthcare force or mandate robust backup strategies. So ultimately, backups are your safety net. You hope you never need them any at all, but you will be grateful that when you'll be grateful they exist if a disaster strikes. There are multiple types of backups. We will talk about them. Let's put all of them here. No, 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 no. Delete this. Can I delete? Yeah, I can. There is let's put them like this. There is a full backup. There is incremental backup. There is a differential backup, and there is what we call transactional log point in time. Let's start with the full backup. A full backup captures your entire database at a single point in time. It's the simplest to restore, but also the most time consuming and storage heavy if you do it frequently. Okay. Number two, we have incremental backups. The incremental backups like only backs up changes since the last backup, whether a full or incremental. It saves storage space and time, but restoring can be slower because you need multiple backups files. Number two, we have the differential backup. The differential backup is similar to the incremental backup. Expect it backs up changes since the last full backup. It's quicker to restore than the incremental because you only need two sets of backups, the latest full and the latest differential. And next we have the transaction log point in time. This one logs every transaction, so you can roll forward your database to precise moment. It's a perfect for mission critical applications needing a minimal data loss in case of failure, like backup system, bank system, or things like that. And in the future, I will create a video for each one of them. In today's video, we only talk about them on a pretty high level. Okay, so next we have a backup strategies. We have a full backup, we have which once a week. We have differential or incremental backups, which is backs up every day. And we have transactional log backup, which backs up every few minutes or hours, depending on your tolerance for data loss. There are some common tool backups for backups like for it's O not A. For like MySQL, there is MySQL dump for logical backups or MySQL Enterprise backup for physical backups. In Postgres, there is Postgres dump for logical, and there is Postgres or BG backrest. For MongoDB, there is MongoDB dump and MongoDB restore, plus the OPS manager for complex scenarios. Additionally, many teams use cloud native solutions like AWS RDS snapshots or Azure SQL backups or other things which automate large portions of backups process. We could also talk about them in more details in some videos in the future, like talk about AWS RDS snapshot and when to use it and like things like that. Okay, so let's talk about restoring your database. Like all the backups in the world meaning nothing if you can't restore them. Um, First thing, we need to identify the right backup. Like which point in time do you need? Do you need the latest snapshot or a specific transaction log? Number two, you need to prepare the environment. Like make sure you have the same the same database software version. It's pretty important. Check disk space and system resources. Number three, perform the restore. Like use the appropriate restore commands for your database. For incremental differential backups, apply the full backup first, then the incrementals or differential in orders. Number four, we have validate data, like run checks or queries to confirm data integrity. Monitor logs for errors in or any inconsistencies. Okay, what are the best practices for backups? Practice. The best practices will be first, you need to do some automation like set up schedule jobs or cron tasks so you never forget to take a backup. Number two, off-site storage, like keep a copy of your backups off-site or in a separate cloud region to avoid losing everything in logical catastrophe or something like that. Number three, encryption, like protect backup files, especially if they contain sensitive data. Number four, retention policy, like define how long you keep older backup storage costs versus recovery needs must be balanced. You need to do that, like storage costs versus the recovery needs must be balanced. Number five, disaster recovery testing. Like at least once a quarter, do a full restore test, document the steps and any issue you encounter. Okay, so let's wrap everything up right now. Whether you managed a small personal project or massive enterprise system, backup and restore process are your lifeline when disaster strikes. By understanding the different backup types, planning a suitable strategy, and testing your restores regularly, you will be equipped to keep your data safe and your systems running smoothly. If you found this video helpful, please hit the like, subscribe, and leave your question or experience with database backups in the comment section below. Thanks for watching this video.